of operating system. The first one is controlling computer hardware. The operating system is the only part which is controlling the CPU, RAM, printers, so disk drivers, etc. And also it will organize the files on the storage media. For example, it is organizing files on the hard drive and the memory cards and in our main memory and all, and it provides the user interface. And it provides security and managing hardware errors, protecting data files, and reporting and logging the hardware and software. So now we will see some of the types of operating system. The first one is the single user operating system. Here, what do you mean by single user operating system is it's a standard operating system for a standalone computer system. So only one person can utilize the computer system at any one time. But and also it will support the multiple accounts in one computer system, but at a time only one user can utilize the computer system. So this is called as the single user computer system. So since the computer person or the customer is only one user, the processing power of the CPU is fully dedicated to the single user. So multitasking can be performed. Okay, so the single user operating system is nothing but that the computer system can be utilized by only one user, and that is why and the full processing power of the CPU is so dedicated to the single user. Multi-user, so here so more than a single user can be but access the system at the same time, and it is most commonly the network operating system. For example, in our computer lab we can use with the help of the network operating system, multi-user can but access the system with the help of the client server LAN. And some of the examples of the ATM ticket booking, at the same time multiple users can but access the ATM and also the ticket booking and also the net banking and all. And also here, so how the OS allocates a time slice to each user, switches from user to user. But in the single user, the CPU is fully dedicated to a single user. But here, since it is a multi-user, the OS allocates a time slice to the each user. So it switches from user to user, and larger the number of users, as we know, when we are trying to access the results and to want to see the results, the server will the server will be very slow. So it can run the several programs simultaneously. So this is the multi-user operating system. And multitasking. What do you mean by multitasking? Is the CPU carries out more than one task at the same time. Okay, several programs can be loaded and running at the same time. For example, multitasking means I can in my laptop I can but open the MS Word at the same time. I can access the PowerPoint at the same time. Also I can browse my internet, email, and also I can use the MS Teams. This is called as the multitasking. CPU carries out more than the one task at the same time, and the processor switches between the task. It completes part of the one task, then switches to do the part of the another task. This process happens very fast, but it appears that tasks are happening concurrently. So the processor will switches from task to task, but so for our eyes it will appears as the task are parallelly running, running parallelly, like that it will appears to our eyes. So true multitasking requires more than the one processor. So many current CPUs have the multiple processing cores. Okay. And then interactive operating system. So direct interaction. So while a program is running, for example, it accepts and responds to the input from the user, and question and answer between the user and the computer. For example, whenever I want to try or whenever I want to purchase from here but online website, it will directly, it is an interactive one. So question and answer session. So how many units you want, according to that it will calculate the amount and it will ask you to and direct you to pay the amount like that. Okay, if your PIN number or some, if you are not having any balance, it won't allow you to so submit the button. So that is the interactive but operating system. So computer that gives you an immediate response is called as the interactive system. So interactive processing, for example, these are all some of the interactive processing: booking concert tickets, ordering books online, and handling bank accounts. So these are all some of the examples for the interactive processing. And the real-time operating system. Real-time is the must response to the events with no discernible delay. So what do you mean by discernible delay, students? So what do you mean by no discernible delay? Hello?
I don't idea about them.
No idea. So discernible delay is nothing but without but even a single delay or a very second delay, so we can say it must respond to the events with no discernible delay. It responds immediately to the data entered. So this type of operating systems required, so where the response time by the system is so very critical. For example, it is but used for the control systems. For example, traffic lights and so air traffic control and so aircraft navigation. These are all the situations where we need the immediate response from the operating system. So that is called as the no discernible delay. Okay, so this type of operating systems are coming under the real-time operating systems. So these are some of the examples. And batch processing. So data can be collected but over a period of time, and when all data collected, it is processed at the same time. So batch processing, by the name itself we know, by batch it will be processed. So data is processed at an off-peak period. When the CPU is not very busy, at that time only it will be processed. So when there is so very less demand on the processor and also very less disturbance to the daily work schedule, and also the system and the peripherals available when most needed. So it does not need any staff intervention. It will automatically process. So in a batch by batch systems. The distributed systems, it is a very complex task. So here in the type of distributed operating system, so a very complex task is split into a number of smaller and the similar tasks. So a series of computers connected together via a network. So computers can be in different physical locations. So each computer performs the part of the processing. For example, so film animation and modeling real world scenarios. So these are all some of the examples for the distributed system. Distributed system is nothing but a very complex task is divided into a number of small tasks, and these number of small tasks are parallelly so executed in the various computers which were located in the different locations, and they will combine the task and so put it into the so only one task. These are all some of the types of operating systems. Okay, so from first single user and multi-user, multitasking, interactive, then so real time, and the batch processing and distributed systems. So till now, so any doubts, students?
Ma'am, could you please explain again distributed system, ma'am?
Okay, distributed systems. Okay, so distributed systems are nothing but, so here a very complex task is split into a number of very smaller tasks. Okay, so here these smaller tasks are so executed in a different so computer systems which were located in a different so locations. For example, imagine some so manufacturing industry and all. Okay, so in the manufacturing industry we have so many departments. Okay, so
Yes,
for
ma'am.
example, marketing department and accounts department, purchase department, and so quality checking department. So like that, we have so many types of department. So they will coordinate the processes. So they will divide the task into the different types. For example, if suppose any customer is ordering for some products in that manufacturing plant, they will divide the task into different. So first they have that customer has to approach the the purchase department. Okay. So sorry, first they will approach the marketing department. So marketing people will communicate to the purchase department according to the requirement of the customer. So they have to communicate to the purchase department. So according to the requirement, the purchase department will buy the raw materials from outside and they will communicate this to the manufacturing department. And after manufacturing all things, this product will be checked by the quality department. And then only it will also go to the dispatch department. No. So here this complex task is so divided into so many little tasks, and it will be processed in different computers, and when it is dispatched to the customer, it will be combined into a single output and dispatched to the customer. So that's what I am telling here. Like that. So here in the film animation and all, so they will so divide the task into different so little tasks, and so do the execution in the single so parallel computers and combine the animation so into a single film. For example, if you see the Avatar film, no, but Avatar film, I hope so lot of animations are there.
Yes, ma'am.
Yes. So like that,
Yes.
in that so movie, it may be a chance for the distributed systems. So they will, so each and every frame will be so executed in different computers, and they will combine into a single cinema. But are you able to understand?
Yes, ma'am. Yes, ma'am. I understand.
So any other so doubts in this?
No, ma'am.
Okay, shall we pass on to the next so topic, students?
Sure, ma'am.
Okay, fine.
Yes, ma'am.
Okay. So next is students. So whether the screen is visible to you now?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes,
Yes,
So
ma'am.
next our topic is so processes. So what do you mean by a process, students? Process means what?
Something happening, ma'am.
Something happening. Yes.
Yes, ma'am.
So,
Program
so
learning.
process is
like that.
nothing but under so yeah, execution. So something is happening at present is called as processes. Okay. So here that we will discuss these types. So these topics. What do you mean by process concept and scheduling and operations on processor and inter-process communication, and also examples of inter-process communication and communication in the client-server systems. Okay, but an operating system executes a variety of programs. Yes, of course, it is so executing a variety of programs. The first one is the batch systems and the time shared systems. Batch systems is nothing but, as I say already, they will collect several jobs into a single batch, and that batch by batch it will execute. And the time shared systems is nothing but so user programs or tasks. Some time will be scheduled for each and so every program, and then only it will be executed with the help of an operating system. That is called as the time shared systems. For each and every process, some time allocation will be there, and within that time allocation, that process should be executed. Okay. So here a process is a program in execution. Okay, so process process execution must progress in the sequential fashion. Process is nothing but program in execution in a sequential fashion. So step by step only. When we are writing a code in a Java or Basic or so any type of language, so in the sequential fashion only, by step by the first line will be executed and the second line, third line, like that only it will be executed. So that is called as the sequential fashion. So a program will always be executed in a sequential fashion. So each and every process comprises this program counter, stack, and the data section. Okay, so these are all the parts of or components of a process. So program counter, stack, and the data section. So this is a pictorial representation for a process in the memory. So stack will be there, and the heap. So memory will be there, heap memory will be there, and the data is there, and the text is there. Students, can you tell me what do you mean by a stack and the heap memory? What is the difference between a stack and the heap memory?
Stack means lost in, first out.
So that's characteristic of a stack. And why do we need stack and why do we need the heap memory? So what's the purpose? So anybody else?
Data in the sequential manner.
Split the data in characters like text data into separate. Split the data.
Once again.
To arrange data in a sequential manner, ma'am, like structural manner.
In a structural manner, okay. So that's a stack.
Hello?
So what are you explaining? Is a stack or a heap memory?
Heap is a dynamic memory allocation.
Very good. Okay, dynamic memory allocation for. Yes, good. So stack and so heap are both of the memories here. As so one of the students said, so in the stack we can store the data. So what are all the so during the process execution, that particularly that process execution, that process will be happen in the dynamic space, that is the heap memory. Okay, the process execution will be happened in the heap memory and the intermediate data will be stored in the stack. Okay, and the permanent data or a local variables or so whatever may be, that will be stored in the data so data space, and what all the text will be stored in the text. Students, are you but able to catch this so concept? So heap space will be utilized by the process for the execution. So this will be differ for so each and every process. Okay, and stack, what are all the intermediate data? For example, if I want to multiply 3 numbers or the 4 numbers, first I will multiply 2 numbers and 3 and then 4. That intermediate data will be stored in the stack. Okay, and the permanent data will be stored in a data. So whatever data which won't be but altered will be stored in the data section, and the text will be stored in the text section. But I hope you but understand this so picture, this figure. Students, are you?
Yes, ma'am.
Yes, ma'am.
So that you has to know the difference between a stack and the heap memory. So these are all very basics of but operating system. So these are all some of the states of the operating process. So here as a process executes, it changes its states like this new, running, waiting, and so ready and terminated. So these are all the states: new, running, waiting, ready, and terminated. So new is nothing but the process is a new process, and running is so instructions are so being executed, and waiting is the process is waiting for some event to occur, and ready, the process is waiting to be assigned to a processes. So there is a slight difference between a waiting and a ready. Okay, so waiting is nothing but the process is waiting for some event to occur. And ready is, it will wait for the processor for the allocation of the processor. And termination, so by name itself, we know the process has so finished its execution. So these are all the states of a process. So this is a pictorial representation. So for the process states, so whenever a process is created, it will be ready for the execution. Okay. So here, so ready means at its time it will be go to the running state and it will so terminate the process. And if suppose some interrupts are coming means the running state process will be but again so coming to the ready state. Okay. So whenever an interrupt is coming during the running of the process, so again this process will be coming to the ready state. And what do you mean by waiting? So during the running process, if suppose whenever we are if suppose I am typing on so text or some para in the Word document, at that time I want to so print some other document at the same time parallelly. So at that time the processor will so give its focus for the printing only, not for the typing. But isn't it or not? I am having two Word documents. So in the first document I am typing one paragraph, and in the second document I want to print the second document. At that time the processor will so give its time to the printing or the typing. Hello.
Printing.
Printing
Yeah,
only at that so that's what so some other so whenever the processor so giving its time for the printer, at that time the typing document will be waiting for the processor. No, that is called as the waiting process. So again it will so go to the ready state. For that printing it will be wait for the printing or but IO or so that's what I so told you. Waiting is nothing but the process is waiting for some event to occur. Okay, so for the completion up to printing that a typing document will so wait and then only it will be yeah. But again go to the running state and it will terminate. So these are all some of the process states. Students, so any doubts in this process states?
Nothing.
No, ma'am.
Okay.
No, ma'am.
So have it in mind: new, ready, running, waiting, and termination. Process control block. So information associated with each processes are process state and program counter and CPU registers and CPU scheduling information, memory management information, accounting information, IO status information. So these are all the details of so each and every processes stored in the process control block. If suppose for so each and every citizen we have this name and this Aadhaar card ID, and also we have a PAN number, and so what are all the IDs we have? So we have a mobile number and we have a car. If suppose if we are having a two-wheeler or a four-wheeler, we have that number. So like that here, so each and every process will have these type of informations, and this will be stored in a process control block. Okay. So how these processes are scheduling? So in a computer, so many processes are coming and also executing with the help of the operating system or with the help of a processor. So how these processes are scheduling? So there should be a scheduling in a process execution now. So for that we have some types of the queues. So job queue and the ready queue and the device queue. What do you mean by a job queue is set of all processes in the system is called as a job queue. And the ready queue is set of all processes residing in the main memory, ready and waiting to execute. So they will be ready in the main memory and they will so wait for the processor allocation time. That is called as the ready queue. And the device queues. So device queues are nothing but set of all processor waiting for an IO device. So processes migrate among the various queues. So a process in a job queue may coming to the ready queue, and so a process in a ready queue may come to the device queue. So like that they will migrate among the various queues. So we have three types of queues: job queues and so ready queues and the device queues. And schedulers. So how these processes are scheduled with the help of schedulers. So we have two types of schedulers. So long-term scheduler and the short-term scheduler. Long-term scheduler is nothing but it selects which processes should be brought into the ready queue. Okay. And short-term scheduler, it selects which process should be executed next and allocates to the CPU. Students, I hope you make the difference between the short-term scheduler and the long-term scheduler. Short-term scheduler is nothing but it will allocate the CPU, and also it will so select which process to be executed next. Okay, so short-term scheduler will allocate the CPU for the processes, and here the long-term scheduler will make the process to so keep in or so stand in a queue. Students, but understandable to you? But I hope you understand.
It will be a large number of, it has some large number of data, so that's why it is been scheduled for the long term. Right?
Yes, yes. And also we have the medium term scheduler is there. So here, so this is the ready queue. As I said, so it will wait for the CPU time, and once it also executes, it will be come to the end state. So this is the waiting state now, as we saw, but already in the states of the processes. And here, so whenever in between, so whenever a process is so swap out, it will, but again partially executed and swapped out of the processes. It again it will be swapping in the ready queue. This is called as the medium term scheduler. So, so medium term scheduler is nothing but the swapped out processes will be, but again swapped in the ready queue with the help of the medium term scheduler. So here processes can be described as so either IO bound process or CPU bound processes. IO bound processor, it spends more time on so doing the IO than the computation. And the CPU bound process, it spends so more time doing the computations. Okay. And so there are so there are many concepts in our operating system. So be attentive to the classes. Okay. So till now we have seen so the definitions are, we have seen very small definitions in a very large so very large numbers now. So what do you mean by operating system, and so why do we need operating system, and what are the types of operating system, and what do you mean by a process, and what do you mean by a process control block, and what do you mean by schedulers, this short time scheduler and a long time scheduler, so like that, and the medium scheduler, and also this IO bound process and the CPU bound process, and the context switch. Then you should so sit and study, then only these concepts will be understandable. Okay, otherwise it will be very confusable to you. So context switch, so when CPU switches to another process, the system must save the status of the old process and so load the saved state for the new process via context switch. So context switch is nothing but whenever a CPU switches from a one process to the next process, it is called as a context switch. Okay. And process creation. So under the process creation, we have two types of processes. First one is parent process and the next one is the child process. So here, but always the parent will create the child process, and the child process in turn create some other child process, which will so forms a tree of processes. So generally process identified and managed via a process identifier. So each and every process will have a process identifier, and how this so resources are sharing between the parents and the child are so this is the one type of sharing of resources. So both the parent and the child will be share all the resources, and sometimes children that share the subset of the parents' resources, and sometimes parent and child will be that no resources will be shared by parent and child. So these are all some of the cases for the resource sharing. So sometimes so both the parent and the child will share the resources. Sometimes they won't share the resources, and sometimes the children only share the subset of the parents' resources. And also the execution, under the execution, parent and the children can but parallelly execute, and the parent waits until the children terminate. Until or otherwise, the children processes will be terminated first, then only the parent will be terminated. Okay. So these are all some of the basic concepts. Okay. So inter-process communication is nothing but processes within a system may be independent or the cooperating. Okay. A process may be independent or a cooperating processes. So cooperating process can affect or be affected by other processes, including sharing data. Okay, cooperating processes are nothing but they will share the resources, and whatever may be the communication, they will communicate with the other processes. What are the reasons for cooperating process or inter-process communication is so during this inter-process communication, information will be shared and computation speed up and modularity and for the convenience. So these are all the reasons for inter-process communication. And cooperating processes that need inter-process communication. So for this type of advantages, so they will share the information, and the computation speed up will be increased, and modularity, they will divide the task and for the convenience. And there are two models of inter-process communication. The first one is the shared memory, and the second one is the message passing. Okay, inter-process communication is nothing but communication between the two or more processes. The two models of IPC is shared memory and the message passing. And so this is the shared memory and message passing. So here the process A and process B, so both the process are sharing this single memory. This is the memory which will be shared by both the process A and process B. So here this is the shared memory model, and this is the communication model. So message passing model. Here the process A will be communicate the message to the kernel, and in turn the kernel will pass the message to the process B. So what do you mean by a kernel? So in operating system, students, what do you mean by a kernel?
Core part of the OS.
Hmm?
Core part of the OS, ma'am.
Yes. So core part of the operating system. So the kernel will come the controller of the operating system. It's a main part, and it's a core part. So here in the message passing model, the process A will communicate the message to the kernel, and in turn the kernel will pass the message to the process B. So these are all the two models of inter-process communication. The first one is the shared memory. So this is the shared memory, and this is the message passing model. And cooperating, so again the same concept only. And so synchronization. So synchronization is nothing but message passing may be either blocking or the non-blocking. Blocking is considered as the synchronous, and non-blocking is considered as the asynchronous. Blocking, so what do you mean by synchronous is nothing but whenever a sender send a message to a receiver, until or otherwise it will get the acknowledge, it won't send the next message to the receiver. That is called as the synchronous. Okay, so whenever a sender send a message to a receiver, it has to get the acknowledge, but after getting the acknowledge only it will send the second message to the receiver. That is called as the synchronous. And what do you mean by asynchronous is, if it won't get the acknowledge, it won't send the message also. It will the blocking, the sending will be blocked here. So that is called as the blocking. Here, not do you mean by asynchronous is the sender will send a message to the receiver. So whether the sender is receiving the acknowledgement or not, it will so continuously send the message to the receiver. That is called as the asynchronous. Students, are you able to understand the so synchronous and the asynchronous? Here in the synchronous, the sender will receive the acknowledgement, but here it won't wait for the acknowledgement. It will continuously send the messages. Okay. So these are all so coming under the processes. So some small so definitions only. Okay, process systems, and so what do you mean by a process in the memory, and process state, and process control block, and scheduling queues and schedulers, and context switch, and process creation and termination, interprocess communication. So these are all coming under the processes. So I am going to the next topic. Once again. Students, the screen is visible to you. CPU scheduling.
Yes, ma'am.
Yes, ma'am.
Okay.
Class name class மட்டும்.
மேம்
Yes.
பிபிடி எல்லாம் ஷேர் பண்ண முடியுமா மேம்?
எஸ்பா, உங்களுக்கு நாங்க கிளாஸ் முடிஞ்சோடனே ஷேர் பண்ணுவேன் ஃபுல்லா at the end of the day. Okay.
ஓகே மேம், தேங்க்யூ மேம்.
தேங்க்யூ மேம்.
இல்லாட்டி உங்களுக்கு இப்பவே வேணுமா, அன்னன்னைக்கே வேணுமா?
வாட்ஸ்அப்ல ஷேர் பண்ணுவீங்களா மேம்?
ஷூர் நான் ஷேர் பண்றேன். இல்ல உங்களுக்கு இப்ப இன்னைக்கு கிளாஸ் முடிஞ்சு வேணும்னாலும் நான் ஷேர் பண்றேன்.
எஸ் மேம், இன்னைக்கு சென்ட் பண்ணீங்கன்னா
it will be better
to understand.
Okay. சரி, ஓகே, நான் இன்னைக்கே ஷேர் பண்றேன்.
தேங்க்யூ.
Thank you, ma'am.
Okay. So CPU scheduling
மேம் எக்ஸாம் ஆன்லைனா ஆஃப்லைனா மேம்?
ஆன்லைன் தான். So நான் உங்களுக்கு லாஸ்ட் ஒரு 5 to 10 minutes தரேன். அப்ப இந்த மாதிரி क्वेश्चंस கேளுங்கப்பா. நான் I will complete the syllabus. Okay.
Okay.
So CPU scheduler. Yes. So what do you mean by CPU scheduling is one of the very important concept in operating system. How the CPU is scheduling the main memory or the processor to the process. So it selects from among the processes in the memory that are so ready to execute and allocates the CPU to one of them. Here the CPU will so select the processes in a ready queue and allocate the memory to the or allocate the CPU to the particular process. So CPU scheduling decisions may take place so when a process switches from running to waiting state and switches from running to ready state and switches from waiting to ready state and terminates. Okay, the CPU scheduling decisions may take place when a process will change from running to waiting, running to ready, and waiting to ready, and terminates. This non-preemptive and preemptive and all I will tell you in the further slides. Okay. Dispatcher. So dispatcher module will gives control of the CPU to the process selected by the short-term scheduler. So in the previous PDF we saw this short-term scheduler and the long-term scheduler. So dispatcher module will gives the control of the CPU to the process selected by the short-term scheduler. This involves switching context and switching to the user mode and jumping to the proper location.
அவன் எதுவுமே கேட்கல, காசு எவ்வளவு வருதுன்னு கூட கேட்கல. டிராப் எங்கன்னு கேட்டா பல்லாரும் போன் வரேன்னு சொல்லிட்டு போன் வச்சிட்டான். இன்னொருத்த புக் இருக்கு அவன்.
ஸ்டூடெண்ட்ஸ், நீங்க வீட்ல பேசும்போது அந்த உங்களோட மைக்கை மியூட் பண்ணிட்டு கூட பேசணும்னு தெரியாதாமா? நீங்க உங்களோட மைக்கை மியூட்ல போட்டு வைங்க. இப்ப என்ன நெசசிட்டி உங்களுக்கு வந்து ஆன்ல போடுறதுக்கு? மத்தவங்களுக்கு டிஸ்டர்பன்ஸ் ஆகுதுல்ல? So scheduling criteria. So how the CPU will select a process for but allocating the CPU. So some criteria should be there, no? So CPU utilization and throughput and turnaround time and waiting time and the response time. For example, scheduling criterion whenever we are allocating seats, for example, in our Anna University, whenever we are doing the counseling, at first they will display the ranking status of the students. Okay. But after completing the +2, the students will apply for the BE in Anna University, and according to some criteria, they will select the students and display the ranking of the students according to some criteria. Like that, here, so how the process or the scheduling criteria will be done? Yes. So CPU utilization and the throughput and the turnaround time and the waiting time and the response time. What do you mean the CPU utilization is? It will keep the CPU but as busy as possible. The scheduling should be keep the CPU. You should not waste the CPU time. And the throughput, the number of processes that complete their execution per time unit. The number of processes should be more. So in a particular time per time unit. Okay. And the turnaround time. The amount of time to execute a particular process is called as the turnaround time. The amount of time to execute a particular process is called as the turnaround time. And waiting time is the amount of time a process has been waiting in the ready queue is called as the waiting time. The time waiting in the process, the ready queue is called as the waiting time, and the response time is amount of time it takes from when a request was submitted until the first response is produced. Response is nothing but whenever it puts a request, it should be responded. So CPU utilization, throughput, turnaround time. So now you tell me, students, the CPU utilization should be maximum or the minimum?
Maximum.
Maximum. Yes, good. The maximum should be the CPU should be utilized. What about the throughput time? This throughput criteria?
Maybe minimum.
The number of processes that complete their execution per unit time. That maximum or minimum?
Minimum.
Minimum.
Huh?
Minimum.
Is it right?
It should be maximum.
It should be maximum.
So that in a short time they can complete more work.
Yes, we can complete the more number of processes. So it should be maximum. So purida students, the CPU utilization maximum throughput maximum. For example, if நம்ம பேங்க்ல கேஷ்க்கு நிக்கிறோம்னு வெச்சுங்களேன், இல்லாட்டி நம்ம டிக்கெட் கவுண்டர்ல நிக்கிறோம்னு வெச்சுங்க. இப்போ அதாவது 2 டிக்கெட் கவுண்டர் இருக்கு. சோ ஒரு டிக்கெட் இஷ்யூ கடகடன்னு கொடுத்தாருன்னா எல்லாரும் அங்க தானே போவோம். ஒருத்தர் ரொம்ப லேட் பண்ணா என்ன பண்ணுவோம்? அங்க உள்ளவங்க இங்க வந்துருவாங்க, அப்படிதானே? நம்ம ரயில்வே டிக்கெட் வாங்கும்போது. Yes ma'am. So the number of processes should be maximum. Okay, the throughput should be maximum. The turnaround time எப்படி இருக்கணும்? அந்த இது the explanation வெச்சு சொல்லுங்க. Amount of time to execute a particular processes. Turnaround time should be
minimum.
Yes, minimum. It should take only a very less amount of time. And waiting time?
It should also minimum.
Minimum. So it should be minimum. And the response time?
Minimum, quickly.
So it should be also minimum. So these are all the scheduling criteria. According to these criteria, the scheduling process will be selected by the CPU. Okay. So CPU utilization should be maximum, and so throughput should be maximum, and the turnaround time should be minimum, and the waiting time and the response time should be minimum. So that's what we are telling here. And here, so these are some of the important concepts, students. Please be attentive. Here we have 6 types of scheduling algorithms. Okay, for the CPU scheduling algorithms, we have totally 6 types of so CPU scheduling algorithms. First one is the first come and first served scheduling, that is the FCFS. உங்களுக்கு இது क्वेश्चन பேப்பர்ல வெறும் FCFSனா கன்ஃபியூஸ் ஆகாதீங்க. first come first served scheduling here. So this is one example for the first come first served scheduling. So these are all the processes, so names P1, P2, P3, and burst time are these. Burst time is nothing but the time required for the process to complete. Okay, burst time is nothing but the time taken by a process for the completion. So suppose the processes arrive in the order P1, P2, P3. The Gantt chart for the schedule is, so this is called as the Gantt chart. Okay, so here in this chart we are mentioning the process names as well as the scheduling time. So processing time here. So since these processes are coming in this order P1, P2, P3, we are so executing this processing in so processes in the same order like that. So since this P1 is taking the 24 seconds, so it will start from 0th second to 24 seconds. It will complete this process. And the P2 will come. So P2, it needs only 3 seconds. So from 24, it will so execute or process for the 3 seconds. So up to 27, it will execute. And but after so from 27 and P3, but also needs 3 seconds. So that is why 27 to 30. Okay. So waiting time for P1 is so only 0 seconds. But for the P2 has to wait up to 24 seconds now. So that is why the P2 is equal to 24, and for the P3 it is equal to 27. So here our but average waiting time is what? 0 plus 24 plus 27 by the number of processes. So since we are having 3 processes, 3 which is equal to 17 seconds. Okay. So this is the first come first served scheduling. Whichever processes are first coming, it will be so executed first. Okay, so this is the average waiting time. So any doubts here, students?
No, ma'am.
No. Okay.
No, ma'am.
No, ma'am.
And second is, suppose that the processes arrive in this order. So in the previous slide, it comes in this order P1, P2, and P3. But if suppose the order is like this, P2, P3, and P1, the Gantt chart, the corresponding so Gantt chart will be like this. So since P2 is coming first, so what is the burst time for the P2? It is 3 only. For P3 also it is 3, and P1 only it is 24. So here P2, since P2 is coming first, it will be served first. So 0 to 3, and P3 is coming next. So 3 to 6. And so P1 is coming at the last. So 6 to, so since it is taking so 24 seconds, so 6 to 30. So here also we are so calculating the waiting time like so for the P1 it will be 6 seconds for the waiting time. For the P2 it is only 0, and for the P3 it is only 3. So average waiting time is 0, 6 plus so 0 plus 3, which comes around 3. So which is better here? Which is better here, previous one or the next one? So see the waiting time here, average waiting time, which comes around 17. But here the waiting time is only 3.
3 seconds.
Okay. So this is the better one. Okay. So much better than the previous case. This is called as the convoy that effect. So what do you mean by convoy so effect is, we have to place the long process should be placed behind the short process. The short processes should be behind the long processes. Okay, this is called as the convoy effect. And the second algorithm is a shortest job first scheduling. So first come first serve pattern, that is the first algorithm. And the next one is the shortest job first scheduling. Here associate with so each process the length of its so next CPU burst. Now the example soldier that it will be understandable to you. So here so SJ that is the shortest job first is optimal. It gives minimum average waiting time for a given set of processes. For example, here, so these are all the processes, and these are all the arrival time, and these are all the burst time. Burst time, as I said already, the process execution time. Okay, here shortest job scheduling chart is here. They will first see the burst time, which process will take very less time. So here, but among these processes, the P4 is having the very less burst time. That is why the P4 will be executed first. And but after the P4, the P1 is having the very less time. So in the ascending order, the P1 will be executed next, and then the P3 will be executed, and then the P2 will be executed here. So according to this, the waiting time will be changed here. So for the P4, so since it is only 0 to 3, and for the P1 it is having 6 seconds. So from 3 to 9, and for the P3 it is around 7. So 9 to 16 and 16 to 24. So here also the average waiting time, it should be calculated like this. We should take from here, not from here. 0, 3, 9, 16. We should not include the last time. Okay. So whenever we are calculating the average waiting time, we should take from the first. We should we should not take this time. Okay. So this is the shortest job first scheduling. Students, are you able to understand the first come first serve and the shortest job first scheduling?
Yes.
Yes,
ma'am, understood.
Yes, ma'am.
Okay. So these are all. So totally, I said totally. So 6 scheduling algorithms are there. So the first one is first come first serve, and the shortest job first, second, and the third one is the priority scheduling. What do you mean priority scheduling is? By the name itself, according to the priority, the scheduling will be there. A priority number is associated with each process. So the CPU is allocated to the process with the highest priority. So here the highest priority is nothing but the smallest integer indicates the highest priority. So here preemptive and the non-preemptive. What do you mean by preemptive and the non-preemptive is? Okay. So preemptive is nothing but whenever a process, so whether it completes its execution or not, it gives its control of that CPU control to the next process. That is called as the preemptive. So preemptive means what? Whether a process complete its execution or not, it give its CPU control to the next process is called as the preemptive. But automatically it will give its CPU time to the next process. That is called as the preemptive. And the non-preemptive is nothing but whenever a process is executing, it won't give its CPU time to the next process. It will complete its execution completely, and then only it will give the CPU time to the next process is called as the non-preemptive. Students, I hope you understand the difference between the preemptive and the non-preemptive.
Yes,
Yes, ma'am.
Yes or no? So preemptive na enna? அது முடிக்குதோ முடியலையோ அது வேலையா நெக்ஸ்ட் ப்ராசஸ் வெயிட்ல இருந்தா ஒரு டயத்துக்கு மேல அந்த CPU டைம் நெக்ஸ்ட் ப்ராசஸ்க்கு அது அலோகேட் பண்ணும். அதாவது ஆட்டோமேட்டிக்கா எனக்கு வேலை முடியுதோ இல்லையோ நான் உனக்கு தரேன் அப்படிங்கிற மாதிரி. பட் நான் ப்ரீஎம்டிவ்ல என்ன ஆகும்? என் வேலையை நீ எவ்வளவு வேணும் சோ வாட் எவர் மே பி தி டைம்
எவ்வளவு நேரம் ஆனாலும் என் வர்க் முடிச்சிடுறேன்.
எவ்வளவு நேரம் ஆனாலும் நான் என் வர்க்க முடிச்சிட்டு தான் நெக்ஸ்ட் ப்ராசஸ்க்கு நான் தருவேன் அப்படிங்கிறது நான் ப்ரீஎம்டிவ். ஓகே. So SJF is a priority scheduling where priority is the predicted next CPU burst time. So okay, இங்க problem நம்ம அப்புறம் பார்ப்போம். First one second. இங்க என்ன problem is priority scheduling னா தெரியும்னா உங்களுக்கு highest priority உள்ளது first execute ஆயிட்டே இருக்கும். இதுல இங்க என்ன problemனு பாத்தீங்கன்னா problem is a starvation. So what do you mean by starvation? But always the low priority processes may never execute. எப்பவுமே highest priority execute ஆயிட்டே இருக்கறனால என்ன ஆகும்? Low priority processes may never execute. And also, so what is the solution for this? That is the aging. So what do you mean by aging? As a time progresses, if for example, 10 processes இருக்குன்னு வெச்சுக்கோங்க. So 10 processல only 5 process or so 6 processக்கு highest priority கொடுக்கறோம்னா மாறி மாறி இது எல்லாமே எக்ஸிக்யூட் ஆயிட்டு இருக்கும். அந்த லாஸ்ட் 4 process வந்து எக்ஸிக்யூட் ஆகாது. So அப்ப அந்த லாஸ்ட் process எப்பதான் எக்ஸிக்யூட் ஆகுது? அது ஒரு ப்ராப்ளம். That is called as the starvation. So in order to solve the solution or the problem, in order to solve the problem, we have one idea called the aging. What do you mean by aging is, as the time progresses, we will wait for some time, and then after that only we have to increase the priority of the processes. We have to change the priority of the process, but in order to execute. Okay, so this is one solution for the starvation problem. Students, I hope you understand the starvation and the aging concept.
Yeah, ma'am. Sure, ma'am.
Yes.
Yeah. You have understood.
Yes, ma'am.
So this is the third type of scheduling algorithm. Okay, priority scheduling. First one is first come first serve and shortest job first and priority scheduling. So what is the problem in priority scheduling is starvation, and the solution for starvation is the aging process.
Ma'am, can you explain aging once again?
Okay. So aging is nothing but starvation. You understand starvation. You understand the problem of starvation?
Yes, ma'am.
Yes, no? Okay,
yes.
Aging is nothing but we will wait for some time for the low priority marked processes to execute. If suppose the low priority processes are not executing for the long time, we should change the priority of the low priority processes so that it may, but also it should be executed. இப்போ ஃபார் எக்ஸாம்பிள் நான் சொன்னேன் இல்லையா, அவுட் ஆஃப் 10 processes லாஸ்ட் 4 processes வந்து லோ ப்ரியாரிட்டி இருந்தா இட் வில் வெயிட் ஃபார் வெரி லாங் டைம். அந்த லோ ப்ரியாரிட்டியும் எக்ஸிக்யூட் ஆகிறதுக்காக என்ன பண்ணுவோம், அந்த 6th or 7th உள்ளத செகண்டாவோ இல்லாட்டி 8th உள்ளத தேர்டாவோ அது மாதிரி we have to change the priority of the processes so that it should be also execute. Yes,
we are changing the priority after sometimes, right, ma'am?
Yes.
Depending upon the waiting time.
Depending upon the waiting time. அதாவது ரொம்ப நேரம் வெயிட் பண்ணுதா இல்லையான்னு செக் பண்ணணும். இப்ப வந்து சில நேரத்துல பாத்தீங்கன்னா இப்ப வந்து ப்ராசஸஸ் ஃபார் எக்ஸாம்பிள் ப்ராசஸஸ் 10னா 10ஆவே இருக்காது. அது ப்ராசஸஸ் வந்து கீப் ஆன் கம்மிங் டு த ப்ராசஸர்னோ. இப்ப ப்ராசஸஸ் வந்து கீப் ஆன் கம்மிங் டு த ப்ராசஸர். வெறும் ஹை ப்ரியாரிட்டி இதுவே அது வந்து எக்ஸிக்யூட் பண்ணிட்டு இருந்தா லோ ப்ரியாரிட்டி எப்பதான் எக்ஸிக்யூட் ஆகுது. So it will wait for some time and then only it will change the priority of the process so that the low priority processes will also execute after some time. That is called as the aging process. Hope you understand, student.
Yes, ma'am. Understand.
Yes. Okay.
Yes, ma'am.
Okay, this is the third type of scheduling, and the fourth type is round robin. So this is an interesting scheduling algorithm. So each process gets a small unit of CPU time. So usually, for example, 10 to 100 milliseconds. After this time has elapsed, the process is preempted and but added to the end of the ready queue. So I hope you understand the concept of preemptive and non-preemptive. Okay. So with the example, I will explain the round robin. Here, this is an example. These are all the processes and these are all the burst time. So the Gantt chart here is, for the round robin scheduling algorithm, always it will be given with the time quantum. Okay, time quantum which is equal to 4 seconds. Here, the Gantt chart should be like this. For the P1, though it is having the execution time or the burst time as the 24, so since the quantum time is only 4, it will first process for the first 4 seconds, and preemptively it should give the processor to the CPU to the P2. So since P2 is having only 3 seconds, it will execute for the 3 seconds, and the processor will come to the P3, and for P3 also the 3 seconds is there, so it will 3 seconds, and P1. So again, but after P3 no more processes are there, so it again come to the P1. So P1, so since the time quantum is equal to 4, it will but again execute for the 4 seconds. and P2, P3 already completed. So it will again so execute for the 4 seconds, 4 seconds, 4 seconds up to 24 seconds. So inge over 4 seconds, inge parunga. So 8 and 12, 16, 20, 24. Students, I hope you understand this. So Gantt chart.
Yes, ma'am.
Excuse me, any doubts in this so Gantt chart?
Can you explain again?
Yes. So here, what do you mean by round robin is nothing but, so in the round robin, a time quantum will be there. So for our example, the time quantum is equal to 4 seconds. So it will first take the process 1. So process 1 will be so executed for the 4 seconds. And but after 4 seconds, automatically the processor will also go to the process 2. Here the P2 is having totally 3 seconds for the execution. So it will execute for the 3 seconds. So 4 to 7. And but again the processor will come to P3. So P3 is also having the total time of 3 seconds. So P3 will execute for the 3 seconds. So 7 to 10. And so here P2 is completed, P3 is completed. So only P1 is there. So again the processor will go to P1. So P1, so since it is having totally 24, it has completed, but already, so 4 seconds only. So since the time quantum is 4 seconds, here again it will, so you execute for the 4 seconds. It will wait for the next process. So whether, so any other processes is coming or not. If, so there are no processes, so again and again the P1 will be executed. Okay, if suppose that, so in between, so any other processes are come, for example, P4, so P5, the processor time will be allocated to the P4. Students, so புரியுதா இது என்ன round robin la?
புரியுது ma'am.
Yes, ma'am.
So இப்ப புரியுதா? அதாவது நம்ம first P1 வந்து 4 seconds வந்து, so எதனால 4 seconds தான் இங்க வந்து execute ஆகுதுன்னா, because the time quantum is equal to 4. So according to the time quantum, it will be executed. So next P2, it will automatically come.
Time is 20 means it will execute 20, and after the circle it will get 4 gets tripled, ma'am.
Once again கேளுங்கப்பா, உங்களோட voice break ஆகுது, சொல்லுங்க.
Yeah, if the time quantum is 20 seconds means if, it will execute 20 and after the 4 will be in rest now, ma'am.
Yes. So that's the concept. According to the time quantum, it will execute. இப்போ உங்களுக்கு இங்க வந்து 4 ஆ இருக்கு, பட் இதோட டோட்டல் ப்ராசஸ் டைமே 3 ஆ இருக்கனால 3 ஓட முடிச்சுக்கும் அதோட வேலையை. So round robin so scheduling algorithm, so it's a preemptive scheduling algorithm. So புரியுதா இப்போ உங்களுக்கு preemptiveனா என்னன்னா?
Yes, ma'am.
So round robin is a preemptive scheduling algorithm. இது மாதிரி உங்களுக்கு வந்து கிளாசிஃபை பண்ண தெரியணும், எந்த scheduling algorithm preemptive, எந்த ஷெட்யூலிங் அல்காரிதம் வந்து நான் ப்ரீஎம்ப்டிவ் அல்காரிதம்னு. சரியா? சோ இப்போ நீங்க முன்னாடி பாத்தீங்கன்னா ஃபர்ஸ்ட் கம் ஃபர்ஸ்ட் சர்வ்லாம் பாத்தீங்கன்னா நான் ப்ரீஎம்ப்டிவ். அது மாதிரி தான் ஷார்ட்டஸ்ட் ஜாப் ஃபர்ஸ்டும். அப்படிதானே?
Yes ma'am.
சோ ரவுண்ட் ராபின் மட்டும் தான் உங்களுக்கு ப்ரீஎம்ப்டிவ் ஷெட்யூலிங் அல்காரிதம். முடிக்குதோ இல்லையோ அந்த 4 செகண்ட்ஸ்க்கு அப்புறம் நெக்ஸ்ட் ப்ராசஸருக்கு அதோட இது போய்டும், அதோட கண்ட்ரோல் போய்டும். சரியா? சோ திஸ் இஸ் a round robin so scheduling algorithm. So shall I go to the next scheduling algorithm?
Yes,
So
sure. Yes, ma'am.
Yes, ma'am. யாரோ டிராவல் பண்ணிட்டே கிளாஸ் அட்டெண்ட் பண்றாங்க போல. So multi-level queue. So ready queue is partitioned into separate queues. So multi-level queues is nothing but, so here, so see here, multi-level queue scheduling. So here okay, ready queue is partitioned into 2 separate queues, so foreground and so background. Okay, so in multi-level queue la they will separate the types of processes into 2 types, so foreground queue and the so background processes. So each queue has its so own scheduling algorithm. So foreground will use the round robin algorithm, and the background processes will be used the first come first serve algorithm. So எது வேணாலும் யூஸ் பண்ணிக்கலாம். நான் இப்போ எக்ஸாம்பிளுக்கு ரவுண்ட் ராபின் அண்ட் ஃபர்ஸ்ட் கம் ஃபர்ஸ்ட் சர்வ் சொல்றேன். ஸோ எந்த டைப் ஆஃப் அல்காரிதம் வேணாலும் அதை வந்து யூஸ் பண்ணிக்கலாம். Scheduling must be done between the queues, fixed priority scheduling and time slice இங்க பாருங்க. So each queue gets a certain amount of CPU time which it can schedule among its processes. That is the 80% to foreground in the round robin and 20% to background. அதாவது இங்க இந்த multi-level queueல 80% of the CPU time will be go to the highest priority of the foreground processes, and only 20% of the CPU time will be allocated to the background processes. Okay, so this is the concept here. Here, so in the multi-level queue scheduling, the first step is what? They will so divide the processes into two queues. First one is the foreground queue and the background queue. And so both the foreground and the background queue will utilize the different scheduling algorithms. And so 80% of the CPU time will be allocated to the foreground queues, and the 20% of the CPU time will be allocated to the background queues. So this is the concept here. So they won't change the queue here. So what do you mean by they won't change the queue here? For example, இப்போ எனக்கு வந்து lowest priority இருக்கு, highest priority இருக்கு, and highest priority ல system process இருக்கு, interactive processes இருக்கு, இதெல்லாம் இருக்கு. I can't change the priority of the process here. The student process, that we can't change the priority of the student process as the highest priority, and also we can't change the system process as the lowest priority here. This is the concept of the multi-level queue schedule. Students, புரியுதா?
Yes, ma'am.
Yes.
Yes, ma'am.
Okay. And this is the fifth type of scheduling algorithm. Okay, multi-level queue scheduling. And the last one is the multi-level so feedback queue. What do you mean by multi-level feedback queue is a process can so move between the various queues. So aging can be implemented this way. So in the previous scheduling algorithm, what I told you, a highest priority process cannot be changed as a lowest priority, and the lowest priority cannot be changed as a highest priority process. But here, in the multi-level feedback queue, we can change the priority of a process. That's why that is called as the aging, no? As I already told you. So aging can be implemented this way, and the multi-level feedback queue scheduler defined by the following parameters. Okay, so here in the multi-level queue, we can so change the priority of a process. So here multi-level feedback queue scheduler defined by the following parameters: number of queues and scheduling algorithms for so each queue. The method used to determine when to upgrade a process and when to degrade a process, and method used to determine which queue a process will enter when that process needs the service. அதாவது இந்த details எல்லாமே multi-level feedback வந்து scheduling algorithmல இருக்கும். So what so when we can upgrade a process, when we can so demote a process, so like that it will tell you. So example of multi-level queue பாருங்க. இங்க so these are all the queues. Okay, here so one process is allotting a so quantum time of the 8. Okay, so 8 but first if suppose consider this process requires totally 32 seconds, but since it is allocating in the first time, so since it is allocating only 8 seconds, this process will be allocated or changed to the next priority. So here the quantum is equal to 16, but again since the total execution time is equal to 32, it won't complete the execution. So execution, that is why it is a so it again comes to the first come first serve basis. So here, so what is the first come first serve basis? It is a non-preemptive scheduling algorithm. So the 16 plus so 8 is 24. So 24. So balance is so 8. So the remaining so 8 seconds will be so executed with the help of the first come first serve scheduling algorithm here. Okay. So this is how we can change the priority of a process in the type of multi-level feedback queue scheduling algorithm. Students, are you able to understand this so example?
Yes, ma'am.
Once again repeat.
Again. Yes, ma'am.
Okay.
Repeat, ma'am.
Okay. So consider one process. So total that burst time, that is the execution time, is equal to 32 seconds. Okay. Consider a process requires totally 32 seconds for its to complete its execution. Here the process is so enter into the first queue. So where it has been allotted only 8 seconds. Okay, but its total seconds is what? It is 32 seconds it requires. So at first it so execute for so 8 seconds. So since it is not completed, it again the priority will come to the second, so highest priority. Here, so in this also the quantum time is equal to 16. But already it has been executed for the 8 seconds, and the second time it has been executed for the 16 seconds. So totally that particular process has completed totally 24 seconds of its so execution time. Okay. So so what is the remaining time for the process? So 32 minus 24 is so 8 seconds. No. So in order to complete this process execution, it again the process priority will be come to the third level, and it will so use this first come first serve priority scheduling priority first come first serve scheduling algorithm, where it is a non-preemptive. So totally it will complete its so execution in the first come first serve, so in this priority level, and it will come out. Frida, again explain panna mama.
Yes, ma'am. Clear, ma'am.
Frida?
Clear, ma'am. Yes, ma'am.
Then what is the main difference between multi-level queue and multi-level feedback queue? So in the multi-level queue, again below described. So what is the main difference between multi-level and so multi-level queue is we can't change the priority here, but in the multi-level so feedback queue we can change the priority. So that's the main difference between multi-level queue and multi-level so feedback queues algorithm. Students, are you able to understand the difference here?
Yes, ma'am.
Okay.
Yes, ma'am.
So these are all the scheduling, that is the CPU scheduling algorithms. First one is first come. So from the first, I told you what are the scheduling criteria, no? So throughput and what is the turnaround. So once again. So CPU utilization, throughput and the turnaround time, waiting time and the response time. These are all the scheduling criteria, and so these are all the types of scheduling algorithms. First come first serve, shortest job first, and the third one is the priority scheduling, and the fourth one is the round robin, multi-level queue and multi-level so feedback queue. So any doubts in this so scheduling algorithm, students?
No, ma'am.
Okay. Shall we pass on to the next concept?
Sure, ma'am.
Okay. Students, next we come to the concept called the threads. So what do you mean by a thread is so execution unit, which consists of its own program counter, a stack, and a set of register is called as a thread. Thread is nothing but அதாவது நீங்க ப்ராசஸ்னா என்னன்னு கேட்கலாம். ப்ராசஸும் எக்ஸிகியூஷன் யூனிட் தான், த்ரெட்டும் எக்ஸிகியூஷன் யூனிட் தான். So then what is the difference between a process and a thread? Process and thread பாத்தீங்கன்னா ப்ராசஸ்ல உள்ள ஒரு யூனிட் தான் த்ரெட். சரியா? ப்ராசஸ நம்ம செவரல் டிவிஷன் பண்ணோம்னா அதுதான் த்ரெட். ஸோ த்ரெட் இஸ் a small execution unit which consists of its own program counter, a stack, and a set of registers. And threads are also known as the lightweight processes. Okay, so threads are a popular way to improve the application through parallelism. So that's what I told. A process, so whenever a process is divided into so many pieces, that is called as a thread. Here, so what is the necessary to divide the processes? In order to attain the parallelism or parallel or concurrent execution, we are dividing the process into so many threads. So here the threads are called as the lightweight processes, and it consists of its own program counter, a stack, and a set of registers. The CPU switches rapidly back and forth among the threads, so giving illusion that the threads are running in parallel. Okay, so these are all some of the types of thread. So single threaded process and multi-threaded process. So this is a so only one thread is executed in a only one thread is there in a process, and this is a multi-threaded process. So here a particular process is divided into 3 threads, and each and every threads are having the this is register, stack, and code, data files, etc. And so there are 2 types of threads. The first one is the user thread and the kernel threads. What do you mean by user threads are? So user threads are above the kernel and without the kernel support. Okay, so these are the threads that application programmer use in their programs. உங்களுக்கு application program na enna, so they don't know inside so what is the software, what are the coding part they don't know, and they don't have any connection with the kernel and all. Just they will utilize the application. For example, if நம்ம ஒரு சென்னை சில்க்ஸோ அல்லது ஏதோ மெட்ப்ளஸ் போனோம்னா only they will that ஒரு அப்ளிகேஷன் டெவலப் பண்ணி கொடுத்துருவாங்க, அதை மட்டும் தான் அவங்க யூஸ் பண்ணுவாங்க. they don't know anything about the coding and all. That is called as the user threads, and kernel threads are supported within the kernel of the OS itself. So, but all modern OS support the kernel level threads, allowing the kernel to perform the multiple simultaneous tasks and to service the multiple kernel systems. So, kernel threads enna pannum? அதுதான் OS ஓட இன்டராக்ட் பண்ணும். சரியா? இன்டராக்ட் பண்ணி so நம்ம என்னென்ன சேஞ்சஸ்லாம் பண்றோமோ அதுக்கு ஏத்த மாதிரி அது அப்ளிகேஷனை சேஞ்ச் பண்ணும். That is called as the kernel threads and the user threads. And so 2 types சொன்னேன் இல்லையா, single threaded and multi-threaded process. இங்க multi-threaded process, it again classified into 3 types: one-to-one model and the one-to-one. The user threads must be mapped to the kernel threads by one of the following strategies. So many-to-one model, one-to-one model, and the many-to-many model. Okay. So what do you mean by many-to-one model? By the name itself we know. So many user threads can be mapped to only one kernel thread. So this kernel thread will control these 4 threads. Okay. And one-to-one model, so one thread is controlled by one kernel. So each and every kernel is called as the one-to-one model. And many-to-many model, so many users will be controlled by the many kernels. That is called as the many-to-many model. So these are all the theory part that you can study by yourself. Okay, so what are the thread libraries and benefits of multi-threading and all? Okay. So I won't. Okay. So these are all about the threads. Students, so till now, any doubts for you?
No, ma'am.
No. Okay. Okay, but I hope so. Today's class is so we can complete up to this, because so many concepts are there. I will take slowly only. I won't so rush up you as well as me. ஓகே, உங்களுக்கு வந்து ஒரே டைப்ல எல்லா கான்செப்ட் எடுத்தா ஒண்ணுமே புரியாது. ஸோ நான் உங்களுக்கு வந்து இன்னைக்கு கிளாஸுக்கு இதோட போதும், இந்த ஸ்டெப்போட போதும். நான் உங்களுக்கு ஐ வில் சென்ட் யூ த நோட்ஸ். ஓகே ஸ்டூடெண்ட்ஸ்?
Okay, ma'am.
Okay.
Thank you, ma'am.
So by tomorrow we yes.
Ma'am, exam வந்து
Ma'am.
சொல்லுங்க.
Online
ma'am,
offline.
exam வந்து ஆன்லைனுக்கு ரெகுலர் ஸ்டூடெண்ட்க்குலாம் ஆன்லைன்ல நடக்குது மேம்.
இல்லையே, ரெகுலருக்குமே ஆஃப்லைன். ஆமா, எஸ் ஆன்லைன்ல தான் நடக்குது.
அப்போ எங்களுக்கு ஆன்லைனா ஆஃப்லைனா மேம்?
இல்லம்மா, உங்களுக்கும் ஆன்லைன் தான் நடக்கும்.
எஸ் மேம், அதான் மேம் லாஸ்ட் நீங்க ஆஃப்லைன் சொன்ன மாதிரி இருந்தது மேம். சோ தட் அந்த டவுட்டுக்காக தான் மேம் கேட்டேன்.
இல்ல லாஸ்ட் டைம் ஆஃப்லைன் சொல்லியிருப்பேன், பட் அதெல்லாமே யுனிவர்சிட்டி டெசிஷன் தானே, நான் அவங்க சொல்லாம நான் சொல்ல முடியாது இல்லையா?
எஸ் மேம். ஓகே மேம், தேங்க்ஸ் மேம்.
ரெகுலருக்கே ஆஃப்லைன் தானே இப்ப சொல்லியிருந்தாங்க.
எஸ் மேம். இல்ல மேம், என்னுடைய பிரதர்லாம் இங்க ஆன்லைன்ல தான் மேம் அட்டென்ட் பண்றாங்க. நியூ காலேஜ்ல தான் என்னுடைய பிரதர் படிக்கிறாரு. அவர்லாம் ஆன்லைன்ல தான் எக்ஸாம் வந்து ஸ்டார்ட் ஆகி அவங்களுக்கு 2 பேப்பர் கிட்ட முடிஞ்சிருச்சு மேம். சோ அதனால தான் கேட்டேன் மேம்.
ஓகே, ரெகுலர்ல பண்றாரா?
எஸ் மேம், நியூ காலேஜ் மேம்.
ஓகே ஃபைன். சரி. ஓகே.
எக்ஸாம் போடல.
எக்ஸாம் எப்ப முடியுது? நம்ம எக்ஸாம் எப்ப முடியுது?
எக்ஸாம் உங்களுக்கு இப்பதானே கிளாसेस ஆரம்பிச்சிருக்கு. சோ they will so open you the portal by next week, I hope so. அதுல இன்டிமேஷன் வந்திருக்கல உங்களுக்கு வெப்சைட்ல?
செகண்ட் வீக்
வந்திருக்குலையா?
February second week.
எஸ். உங்களுக்கு மோஸ்ட் ப்ராபபிலி ஆஃப்டர் March 15th தான் இருக்கலாம், அப்ராக்சிமேட்லி சொல்றேன்.
ஓகே மேம், थैंक यू மேம். ஓகே
மேம், இந்த கிளாஸோட ஓவரால் நெக்ஸ்ட் கிளாஸ் இருக்கா மேம்?
நெக்ஸ்ட் கிளாஸ் நாளைக்கு போட்டுருவோமேப்பா.
இல்ல மேம், இன்னைக்கு 2 கிளாஸ் போட்டுந்த மாதிரி இருந்தது மேம். சோ அதனால கேட்டேன் மேம். இதோட ஓவர்ல மேம்?
ஆமா, இதோட ஓவர் தான். ஏன்னா நான் I don't want to so stuff you students.
Yes ma'am, thanks ma'am.
So that's why I so leave you by 4:40 itself. Okay.
Questions
what about practical ma'am?
What about practicals? Practicals, since your so exams are on but online, there won't be any physical classes for you practicals, for your practicals.
Practicals ஆன்லைன்ல தான மேம் இருக்கும்?
ஓகே மேம், practicals உங்களுக்கு ஆன்லைன்ல தான் இருக்கும். ஆன்லைன் இந்த சென்ஸ் இப்ப பிசிக்கலா நம்ம பண்ணும்போது நீங்க இங்க வந்து லேப்ல வந்து எக்ஸிக்யூட் பண்ணி எல்லாம் பண்ணுவீங்க, ப்ரோக்ராம் எழுதி எக்ஸிக்யூட்லாம் பண்ணுவீங்க. But so since it is but online process, that you won't come to the so lab, so like your so theory papers, that you will so write your practical exams also through online.
What are the important topics in this subject? Can you please send me the PPT?
Yes. So definitely I will send you the PPT. I hope all of you are in your so group.
மேம், பிபிடில நிறைய டாபிக்ஸ் இருக்கு. ஏதாவது ஸ்பெசிபிக் டாபிக்ஸ் இருக்கா மேம்? லைக் ஃபோக்கஸ் பண்ணி பார்க்கணும்ன்ற மாதிரி ஏதாவது?
ஓஎஸ்லயா?
எஸ் மேம்.
இப்ப நான் நடத்துறது எல்லாமே நான் ஃபோக்கஸ் பண்ணி தான்ப்பா நடத்துறேன். நான் எல்லாத்தையுமே இது, அதாவது நான் இந்த சென்ஸ் உங்களுக்கு வந்து யூனிட் வைஸ் தான் நடத்துறேன். ஸோ வாட் ஆல் த டாபிக்ஸ் நான் உங்களுக்கு கவர் பண்ணி நடத்துறேனோ அதை மட்டும் இது பார்த்தாலே போதும் உங்களுக்கு.
ஓகே, தேங்க் யூ.
ஃபார் எக்ஸாம்பிள் நான் உங்களுக்கு வந்து ஷெட்யூலிங் அல்காரிதம் சொன்னேன் இல்லையா?
எஸ் மேம்.
எஸ், ஷெட்யூலிங் அல்காரிதம் இந்த த்ரெட்ஸ். இனிமே
எக்ஸாம் எப்போ ஸ்டார்ட் ஆகுதுன்னு ஐடியா இருக்கா மேம்?
புரியலமா? எக்ஸாம்
எப்போ ஸ்டார்ட் ஆகுதுன்னு ஐடியா இருக்குமா மேம்?
அதான் சொன்னேன், செகண்ட் வீக் ஆஃப் மார்ச்ல உங்களுக்கு வர சான்ஸ் இருக்கு.
ஓகே, thank you மேம்.
மேம், இன்டர்னல் எக்ஸாம் எப்படி மேம் இருக்கும்?
இன்டர்னல் எக்ஸாம்ஸ் உங்களுக்கு வந்து எம்சிக்யூஸா இருக்கும், பட் ஆன்லைன்ல தான்.
அது இல்ல, டேட் அந்த மாதிரி எப்படி மேம் இருக்கும்? முன்னாடியே வைப்பாங்களா?
அத நீங்க எல்லாம் வந்து once you enrolled in the Madras University, that is the Institute of Distance Education, you have to watch your website daily. Okay. ஸோ உங்களுக்கு ஸோ எல்லா அனௌன்ஸ்மெண்ட்டும் உங்களுக்கு வெப்சைட்ல தான் வரும். ஸோ தே வில் ஸோ கிவ் யூ a specific time gap for completing the internal assessment. Okay?
Okay, ma'am.
So MCQs are but objective type questions.
ஆன்லைன் எக்ஸாம்னா எப்படி மல்டிபிள் சாய்ஸ் क्वेश्चंस மாதிரி இருக்குமா மேம்?
இல்ல உங்களுக்கு எல்லாமே எழுதி அனுப்புறாங்க. உங்களோட பிசிக்கல்ல எப்படி எழுதுவீங்களோ 3 hours அது மாதிரி தான் இருக்கும்.
ஓகே மேம்.
மேம் கொஞ்சம் அட்டெண்டன்ஸ் பத்தி கொஞ்சம் சொல்லுங்க மேம்.
அட்டெண்டன்ஸ் சோ அத சொல்றேன் ஃபர்ஸ்ட். So whenever you are so entering into the class, so உங்களை கேக்கும்ல நேம் என்னன்னு சொல்லி. So just to enter your so roll number, so more than the rather than your name, so that I will so download the attendance.
Sure.
மேம் நாங்க chat boxல எல்லாரும் நேம் மென்ஷன் பண்ணி ரோல் நம்பர் மென்ஷன் பண்ணி போட்டுறோம் மேம். இட் எனஃப் ஃபார் தட் மேம்.
chat box ஓகே, பட் எனக்கு நீங்க இங்கேயே போடிங்கனா இது எனக்கு ஒரு எக்ஸல் ஷீட்டா வந்துரும்.
இப்போ
மேம் சப்போஸ் அட்டெண்டன்ஸ்ல நம்ம நேம் மட்டும் கொடுத்துறோம்னா அது எப்படி மேம் ஐடென்டிஃபை பண்ணுவீங்க?
இல்ல நீங்க இப்ப இன்னைக்கு கிளாஸ் விட்டுருங்க, நாளையில இருந்து அது மாதிரி பண்ணுங்க. பட் chat box போட்டால அதுவும் we can collect from the chat box, பட் இது ஆட்டோமேட்டிக்கா எங்களுக்கு ஒரு எக்ஸல் ஷீட்டாவே டவுன்லோட் ஆயிடும்.
அட்டெண்டன்ஸ்னால எனி ப்ராப்ளம்
டெஸ்க்டாப் யூஸ் பண்றவங்களுக்கு chat box
அதெல்லாம் ஒண்ணாகாது.
பெட்டரா இருக்கு. டெஸ்க்டாப்ல யூஸ் பண்றவங்களுக்கு chat box ஆப்ஷனே கிடையாது மேம். எனக்குலாம் காட்ட மாட்டேங்குது chat box. சோ நீங்க இப்படி டவுன்லோட் பண்றது கரெக்ட்டா இருக்கும் மேம்.
சரி ஓகே ஃபைன். சரி
மேம் எங்களுக்கு அந்த மாதிரி ஆப்ஷன்ஸ் காட்ட மாட்டேங்குது.
மேம் ரீநேம் எனேபிள் பண்ணா இங்கே கூட பண்ணிடலாம் மேம். ப்ளீஸ் எனேபிள் ரீநேம் மேம்.
எனேபிள் ரீநேம் சரி ஓகே நான் பண்ணிடுறேன்.
மேம் C++ம் அக்கவுண்ட்ஸ் கிளாஸும் நேம் வச்சு லாகின் பண்ணவங்களுக்குலாம் எப்படி மேம்?
நம்ம C++ம்
அக்கவுண்ட்ஸ் கிளாஸும் நான் நேம் வச்சு லாகின் பண்ணி வந்திருந்தேன் மேம். நீங்க இன்னைக்கு சொன்ன உடனே நான் இன்னைக்கு தான் ரோல் நம்பர் போட்டு இது லாகின் பண்ணியிருக்கேன். அப்ப அந்த 2 கிளாஸ்க்கு அட்டெண்டன்ஸ் எப்படி இருக்கும் மேம்?
அதுக்கு உங்களோட நேம் வச்சு பண்ணிருக்கீங்களா?
ஆமா.
சரிமா, அது so they will download the அவங்க ஆல்ரெடி இப்ப இந்த அட்டெண்டன்ஸ் எக்ஸல் ஷீட்டா டவுன்லோட் பண்ணிருப்பாங்க. சோ நாங்க ஃபில்டர் பண்ணும்போது உங்க நேம் எல்லா அதுலயும் இருந்தா உங்களோட அட்டெண்டன்ஸ் இருக்கும், அவ்வளவுதான்.
இல்ல என் நம்பர் நான் அனுப்பணுமா மேம்?
இல்ல chat அனுப்பிருக்கீங்களா? chat பாக்ஸ்ல போட்டுருக்கீங்களா?
மேம் ஸ்டார்டிங்ல இருந்து எல்லா கிளாஸுக்குமே வெறும் chat boxல தான் மேம் நாங்க எல்லாருமே போட்டு வந்திருக்கோம். யாருமே கெஸ்ட் ரூல்ல ஜாயின் பண்ணும்போது அவங்களுடைய என்ரோல்மெண்ட் கொடுத்து ஜாயின் பண்ணல மேம். ஸோ அதுக்கு பதிலாக அட்டெண்டன்ஸுக்கு ஃபேவரா நாங்க சாட் பாக்ஸ்ல தான் எல்லாரும் போட்டோம் மேம். ஸோ இப்ப அந்த மாதிரி போட்டது அட்டெண்டன்ஸ் எடுத்துப்பாங்களா அப்படின்னு சொல்லி கேக்குறாங்க மேம். இதுக்கு முன்னாடி போட்ட கிளாஸ் தான் அக்கௌண்ட்ஸ் C++.
அதான் ஸ்டூடெண்ட்ஸ், so being you are a first semester students, we will take the attendance. So whether it is a roll number or a name, because we are having one so list with us. For example, so in your batch, so totally 1300 students are there. Okay, so we have your list with so roll number and the names and what are the details that you so gave so during the admission. So அதை மேட்ச் பண்ணி நாங்க உங்களோட அட்டெண்டன்ஸ் எடுத்துப்போம். So don't worry about the attendance, but so in future please attend the classes with your so roll numbers. It will be better.
Okay ma'am.
Okay
ma'am, is that attendance important ma'am?
ஆமா, உங்களோட இதுல நம்ம கம்ப்யூட்டர் சயின்ஸ்ல இம்பார்ட்டன்ட் தான், கம்பல்சரி.
ஓகே மேம்.
மேம் பிராக்டிகல் எக்ஸாம் ஆன்லைன்ல இருக்குமா எப்படி மேம்? பிராக்டிகல் எக்ஸாம்ஸ்
இப்பதானே சொன்னேன், அதுவும் ஆன்லைன்ல தான் இருக்கும்.
ஓகே மேம்.
மேம் இந்த OS கிளாஸ் இன்னைக்கு நாளைக்கு ஒரு நாள், அப்புறம் 12th தானே உங்களுக்கு?
ஆமா, நாளைக்கு ஒரு 2 hours, அப்புறம் 12th, அதாவது நெக்ஸ்ட் சாட்டர்டே. So any other doubts?
மேம் ஸ்டூடண்ட் லாகின் ஓபன் ஆக மாட்டேங்குது.
ஸ்டூடண்ட் லாகின் எதுக்கு ஓபன் ஆகல?
Yeah ma'am, I couldn't log in.
Wrong numberன்னு வருது, enrollment number wrong.
February 2nd week தான் ஓபன் ஆகும் எல்லாருக்கும். ஆல்ரெடி இன்ஃபர்மேஷன் உங்களுக்கு வெப்சைட்ல கொடுத்திருக்காங்க. A21 பேட்ச் எல்லாருக்குமே.
ஓகே ஓகே ஓகே.
நீங்க அவங்க அனௌன்ஸ் பண்ணதுக்கு அப்புறம் தான் நீங்க ஓபன் பண்ண ட்ரை பண்ணனும், அல்லாட்டி அது மாதிரி மிஸ்டேக் தான் வரும்.
Okay ma'am, thanks ma'am.
Okay ma'am, thank you, bye.
Thank you, ma'am.
Thank you,
Bye.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
அதான் மேம்